Good day, everyone. It's me again, Teacher Agnes, and welcome to my Sipnayan tutorial. Still on the most essential learning competencies of Mathematics 10, Lesson 3 of Quarter 1, Introduction to Geometric Sequence. Learning Competency Code M10AL-1B-1. And for today's video, you are going to illustrate a geometric sequence and identify whether a sequence is geometric or not. Let's begin by finding the ratio of the second number to the first number. Number 1, 2 and 10. The answer is 5. Because 10 divided by 2 is equal to 5. Number 2, negative 3 and 12. The answer is negative 4 because 12 divided by negative 3 is equal to negative 4. Number 3, 1 and 1/4. The answer is 1/4 because 1/4 divided by 1 is equal to 1/4. Number 4, negative 10 and negative 50. The answer is 5 because negative 50 divided by negative 10 is equal to 5. And lastly, number 5, 16 and 8. And the answer is 1/2 because 8 divided by 16 is equal to 1/2. So what is a ratio? A ratio is a relationship between two quantities normally expressed as the quotient of one divided by the other. All answers we got in the previous activity, 10 divided by 2 equals 5, 12 divided by negative 3 equals negative 4, 1/2 divided by 1 equals 1/4, negative 50 divided by negative 10 equals 5, and 8 divided by 16 equals 1/2. 5, negative 4, 1/4, 5, and 1/2 are examples of ratio. We need the concept of ratio in order to understand the next sequence. And now, let's explore the next activity. Divide the first number by the second number whenever possible. Record the result from the least to the greatest. Number 1, 54 and 3. Fifty-four divided by 3 equals 18, divided by 3 equals 6, divided by 3 equals 2. Arranging the ratios from the least to the greatest, we have 2, 6, and 18. Number 2, 32 and 2. Thirty-two divided by 2 equals 16, divided by 2 equals 8, divided by 2 equals 4, divided by 2 equals 2, and divided by 2 equals 1. So the ratios are 1, 2, 4, 8, and 16. Number 3, 375 and 5. 375 divided by 5 equals 75. Divided by 5 equals 15. Divided by 5 equals 3. The numbers are 3, 15, and 75. Notice the sequence formed by the quotients arranged from the least to the greatest. These three are examples of geometric sequence. The next number could be obtained by multiplying the preceding number by the divisor used. In geometric sequence, that constant number multiplied to the preceding number to obtain the next is called common ratio. Let me consider an 8 by 8 paper square with an area of 64 square units. Fold the four corners to the center of the square and find the area of the resulting square. Repeat the process 3 times and record the results in the table. What is the area of the square formed after the first fold? The answer is 16 square units. Since the 8 by 8 paper square will be folded to the center, then the dimension of the sides would be half. So the resulting square paper will have dimensions 4 units by 4 units, getting the area 4 times 4 equals 16. So the resulting area after the first fold is 16 square units. What is the area of the square formed after the second fold? The answer is 4 square units. Since the 4 by 4 paper square will be folded to the center, then the dimension of the sides would be half. So, the resulting square paper will have 2 units times 2 units, getting the area 2 times 2 equals 4. So, the resulting area after the second fold is 4 square units. What is the area of the square formed after the third fold? The answer is 1 square unit. Since the 2 by 2 paper will be folded to the center, then the dimension of the sides would be half. So the resulting square paper has an area of 1 square unit. Is there a pattern in the areas obtained after 3 folds? The answer is yes. If we're going to look at the numbers or the area from the table, we have 16, 4, and 1. 16 divided by 4 equals 4. Divided by 4 equals 1. Is there a common ratio from 16, 4, and 1? The answer is yes. As we can see that we have a common divisor 4, which is the common ratio. Hence, 16, 4, and 1 is an example of a geometric sequence because it has a common ratio, and that common ratio is 4. Now, what is the fourth term? The fourth term is 1/4. Since 16 divided by 4 equals 4, divided by 4 equals 1, divided by 4 equals 1/4. We have a common divisor 4, which is the common ratio. So the fourth term of the geometric sequence is 1/4. Now, let's try to identify whether the following is geometric or not. If it is, find the common ratio. Let's begin with number 1. (10, 40, 160, and 640). It is a geometric sequence. What is the common ratio? 40 divided by 10 equals 4. 160 divided by 40 equals 4. And 640 divided by 160 equals 4. And so, the common ratio is 4. Let's proceed with number 2. 7 square root of 3, 5 square root of 3, 3 square root of 3, and square root of 3. It is not a geometric sequence. It does not have a common ratio. Number 3. 5, negative 15, 45, and negative 135. It is a geometric sequence. What is the common ratio? Negative 15 divided by 5 equals negative 3. 45 divided by negative 15 is negative 3, and negative 135 divided by 45 is negative 3. Clearly, the common ratio is negative 3. Number 4. 1, 0.5, 0.25, and 0.125. It is a geometric sequence. 0.5 divided by 1 is 0.5. 0.25 divided by 0.5 equals 0.5. And 0.125 divided by 0.25 is 0.5. The common ratio is 0.5. (10 over 3, 10 over 6, 10 over 9, 10 over 12, and 10 over 15. It is not a geometric sequence. It doesn't have a common ratio. Now, let's try to investigate the situation in the picture. The amount of water in the bottle doubles every second. It is consistent until the bottle is filled with water, having 100 milliliters after 1 second. Record your observations in 5 seconds. The table now has 100, 200, 400, 800, and 1,600 milliliters. Is the sequence geometric? The sequence is geometric. From the table above, the volume of water in ml is doubled, so the common ratio is 2. So what is a geometric sequence? It is a sequence where each term after the first is obtained by multiplying the preceding term by a non-zero constant called the common ratio. Now, it's time to test yourself. State whether each of the following sequences is a geometric sequence or not. If it is, give the common ratio. Let's start with number 1. 3, 12, 48, 192, and 768. It is a geometric sequence. Its common ratio is 4. Number 2. 1/2, 1, 2, 4, and 8. It is a geometric sequence. Its common ratio is 2. Number 3. -5, -8, -13, -21, and -34. It is not a geometric sequence. It doesn't have a common ratio. Number 4. 625, 125, 25, and 5. It is a geometric sequence. Its common ratio is 1/5. And now, to recapitulate our episode about geometric sequences, ratio plays an important role in identifying geometric sequences. And we can say that a sequence is a geometric sequence if it has a common ratio. Did you learn something today? I hope so. Don't forget to subscribe and hit the notification bell for more of my Sitnayan series. Again, this is Teacher Agnes saying thank you for watching, God bless, and keep safe always. Bye for now. See you next time.